have this question, move zeros. So what basically we have to do is we have to move all the zeros to the end of the array, and we should maintain the relative order of all the other elements, and it should be in place without making a copy. If it was like making a copy, then it would have been just copying all the elements, non-zero elements to the new array, and then making the rest of the array at zero. But again, we can use the same thing in the same array itself. So what we can do is, if we encounter a non-zero number, we move it to the starting, and that's how we fill all the non-zero, and the rest we can fill with zeros. Basically override all these 3 and 12, which have already been moved to the first part of the array. And another, I'll talk about the other approach, which is a 2 point approach later, after showing the basically the solution of the first implementation. So uh, we are seeing that if the number at the ith position is non-zero, then we move it to the start of the array. Non-zero is just the indices of all the non-zero elements, and then we are doing nothing but filling all the rest of the array with zero. And yeah, this basically works. We can it's accepted. We can also look at the other solution, which says that we will be using 2 pointers. So what we do is, we are at 0 and we are at 1. So we see if the ith item is non-zero, then we don't have to swap. So we just ignore that. And also ith and j, so jth is just comparing and pulling it towards the left half. So now what we do is, we move to, so here j I is 0, so we swap with j. J is basically at 1. And then we have something like, if it is 0, then we just swap. If it is not 0, then we do nothing. And if both are zeros, then we just increment. So let's say we have something like 100, so 100, then 3 and 12. So this is the case. So if we are at 1, so and the other is 0, we don't do anything. Then we are at 0, and the other pointer is at 0. So again, so in that case, we move the jth pointer, but we keep the ith pointer at the same location. So this is exactly what we have done in this implementation. So if the number I at ith pointer is 0, so we initialize ith as 0, j is 1. So if we have ith as 0, so at jth position we have two options: either it will be 0 or non-zero. So if it is 0, if it is non-zero, then we just swap, because we want all the non-zero to be in the first, like, initial part of the array, and increase the I also, the left pointer, as well as jth pointer also. So since if it is 0, then we only increase the jth pointer, that's why we have combined these two. And else we have this thing. So if in nums of I is not equal to 0, in that case we just ignore it. So I plus plus and j plus plus, and this also works like a charm. Yeah, it's accepted. So let's see. So we have these two, and yeah, so the runtime is 12 seconds. It's accepted. That's all, folks.